Hey students, we're going to go over how to measure correctly the correct number of significant figures. So significant figures, we're going to be on page 3 in the packet. So first off, what is a significant figure? Well, a significant figure is talking about how precise the measuring device is. The more precise the measuring device, the better and more digits we can get to express the value of that particular measurement. So you can see here that we have a measuring tool and that each of these little tick marks represents an increase of a tenth. And when we look at the increase or the zoomed in picture here, we can see that the pen is not falling directly on the 7th tick mark or the 8th tick mark, but it's in between here. When you're measuring, you always want to estimate one extra digit. So we know that this is 4 something, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. We can record this answer as either 4.72 or 4.73. It doesn't really matter what that extra digit is, as long as you are estimating to that extra digit. So here you can see that we have 2 different measuring devices. The one that's on the top is more precise because each little tick mark represents an increase of a tenth, whereas the one on the bottom is less precise because we only have a measuring of an increase of 1 from one tick to the next tick. So you can see that our answers, our recorded values for the measurement would be different based on the preciseness of the measuring device. So on the top ruler here, we can see that the cylinder measures between the 5th and the 6th tick mark. So we can say it's 2.5, and then this 5 represents that it's in between the 5th and the 6th tick mark. Whereas this one, we can see that somewhere between the 2 and the 3, so when we estimate that extra digit, we can only go to the tenths place, indicating that this ruler is less precise than the ruler up on the top. Oops. When you're measuring liquid in a graduated cylinder, what you want to do is you want to make sure you're measuring from the bottom of the meniscus, the bottom of the curve here. When you're measuring, always look to see what each line represents. Each tick here represents an increase of 1. So we know this is 41, 2, 3, 4. It's 44 point something. It has to be point something to estimate that extra digit. So we could record this value as 44.8. Here with our thermometers, we can see that the top one is less precise. The bottom one is more precise. The top ruler, or thermometer, excuse me, only shows an increase of 1. So when we estimate an extra digit, we can only go to the tenths place. We could say it's 21.7. Whereas down here, each little tick mark represents an increase of a tenth. So we have right here, so we know that this is 21.56, 21.68, 21.69. As long as we are representing to the hundredths place on this thermometer, because that thermometer is more precise. So first off, don't worry about this triple beam balance here. We're not going to use triple beam balances. So preciseness of the measuring devices. Here, you want to make sure that you estimate one extra digit, so we can only go to the tenths place. So we could say it's 2.8, you could say 2.7. Here, each line represents an increase of a tenth, so we know it's 2.567, 2.7 something. We can say it's 2.71. This one, each tick represents an increase of 10, so we estimate to the ones position. We can only say it's like 28 or 27. We cannot put anything behind the decimal point on this one. And then here, each line represents an increase of 1. So we have 25.67. So we estimate one extra position. We could say it's 21.7. The beaker down here, each line represents an increase of 10. So when we estimate an extra digit, it's to the ones position. So we could say this is 48. We could say it's 47, as long as we estimate that extra digit. And we don't give a decimal point on that one. The next video is going to go over counting significant figures.